The first lecture of the day is from Kingfa Science and Technology India Limited. I request Dr. Saroj Samantaray to take the seat. I request the audience to be seated. Dr. Saroj is a polymer engineering professional with a PhD from IIT Delhi. He has specialized in fracture mechanics and structural property relationship with polymers. As R&D manager at Kingfa India, he leads the development of flame retardant composites for automotive and electrical and electronic applications. He has prior experience at Sahajanand Medical Technologies, where he worked on developing multi-layer medical tubing for angioplasty application. His work spans polymer blends, EMI sheeting and sustainable materials, supported by several peer-reviewed publications and strong expertise in processing and material characterization. Dr. Saroj also leads application development related to the use of engineering plastics in automotive appliances and other engineering segments. His ability to use analytical instruments for material engineering helps him with successful project completions. Over to Dr. Saroj.
Good morning, all of you. I will explain the brief introductions about Kingfa Science and Technology India. So, Kingfa Science and Technology India, it is the extended part of Kingfa family. It is located in China. So, we are dealing with the engineering plastic, commodity plastic for automotive and home appliance applications. I will go through the portfolio of Kingfa Science and Technology with the new sustainable and innovative solutions what we have developed in the last couple of years. So there will be a few couple of slides about the Kingfa group. Kingfa established in 1993 in Guangzhou. It is one of the industrial capital of China. So we are moving to the research, production and sales of the advanced polymer material. So one of the biggest advantages of Kingfa that we make our products in the compounded products for the tailor-made applications. What is the customer demand? We make for the customer applications. And in Shanghai, we are listed in 2024, and we have global 19 factories across the globe and almost 11,000 plus employees. And last year, our revenue was 8.35 billion. It's compared to previous year 26% higher. So this is the global layout of Kingfa. In India, we have 3 different locations, manufacturing locations at Pune, Chakan, Pondicherry, and in North Maharashtra. And globally, from the USA and from the Europe, also we have multiple factories. And these are our expansion plan for Southeast Asia, Europe, and North America and South Africa. South Africa is coming under the Kingfa India operations. In the product portfolio, from based on the actually polymer compounds, we classified based on the service temperature, from the commodity plastic to high performance polymers. So Kingfa has all the solutions. The polymers, those are marked with the blue color. We have in-house polymerizations for them. And as I mentioned, for the tailored plastic compounding from functional applications as stabilizations and for the alcohol resistance for the automotive and the fire retardant composites from engineering plastic and commodity also. And during the extrusion processes, compounding, we do with a lot of additives. This is required for the daily uses and functional applications. This is about the Kingfa India in 2023. It was established as a hydroacid and Kingfa China taken over the hydroacid in 2013, and we have listed in both the stock exchange, BSE and NSE. And now we have, as I said, we have 3 manufacturing locations, and if you could see our revenue starts from 2013 to till date, so continuously we are growing and revenue to scaled up in every year. These are the testing facility, actually all the analytical facility those are required for basic material development and formulations we have. And plant is testing facility is recently certified by the NABL, so any third party samples also we can test our facility. So now we come to the solutions what Kingfa has developed in the last years. I will start with the automotive one. In automotive, there is a four major thing where we are working more. One is to the new engineering polymer. This is comprised of lightweight and polyolefin-based functional part. And for the new functionalizations, the light transmissions and the electromagnetic shielding, I will explain one by one each one. And for the compatibility, fabric effect and soft touch, low loss. And as I in the inauguration sections, many of the speakers raised the concern of sustainability. Kingfa is also developed multiple solutions to counter the sustainability aspects. So we have developed compounded with the PCR and PI compound. And as I may see our target in 2030, so we need to achieve almost 36% of neutral carbon. And from the new engineering, the polyolefin-based functional parts, generally functional parts measure into the engineering polymer like polyamides. So we are replacing with the PP. So PP recircularity is higher and you see comparatively more profitable in case of if you compare with the polyamides. And in class of the PCR and PIR, so we have multiple certifications from the global bodies. This is the thin wall material. So generally in the bumper cases, if you could see from the 1970, the thickness was more than 4 mm, but since recent time it is closer to 2 to 2.5 mm. So in this class, so we have developed our PP polypropylene compound with more synergy to counter the larger bumper parts with the greater flowability. So as I mentioned, this MFR requirement is more than 30 and modulus also meeting all the requirement. So we have developed the thin wall material. So it is almost 32% LC reductions you could see to the traditional bumper material. So it's a formed material. So we are importing. We're introducing the nitrogens or chemical growing agents to the PP compounds, measured into the polypropylene only during the injection molding. And this is comprised of the two types: physical formed and chemical formed one. So if you could see almost 20 to 30% weight reductions we have seen in China. So multiple customers, automotive customers, they are now commercially using this formed materials. So as I mentioned, the polyolefinizations, one is to the weight reductions and another one aspect is for the recircularity. So traditionally the inlet outlet canister, this is the functional parts for the automotive, they are used by the PA6 and PA66 with the 30% glass weight. It has been replaced with the special kind of additive we are using with PP with 30% glass weight. So if you could see the resistance to the alcohol also quite superior compared to the PS6 and double-6 because it is comparatively less polar to the polyamides. And this is a major functional part molders. So we are supplying our materials for both in engineering and commodity plastics. So as I mentioned, the new technology trend, the translucent TPO, the thermoplastic or polyolefins. Traditionally, the traditional polycarbonate we use for this kind of applications, but we have replaced with the TPO by multi-layer etching by the laser. So these are the in China, 3 to 4 automotive OEMs they are using this material. And electromagnetic shielding these days, the electrifications of the electric vehicle and massive introductions of the EV vehicles, the sensors and the radar systems requires the protection towards the unwanted electromagnetic radiation. So in Kingfa we have developed our metal with the carbon nanotube and the graphene. So we have achieved a certain level of electromagnetic sitting more than the 38 decimal. And we have our patented grade for the electromagnetic sealing. And this compatibility soft touch one for because of electrifications and requirement from the customer size soft touch, which has a lower gloss, and the hardness also comparatively much lower to the traditionally based material. So from the polyolefin based elastomer and PP, one of the combinations, and we have developed a certain recipe to meet the low gloss criteria. And this material we are using by the BYD and Nissan, VW and other customers also. So this is the materials for the battery overview. For the EV sector, from the battery pack, from starting to the top, cover to bottom, and all the modules, Kingfa has developed the solutions, and measure to all the EV makers in the China and other European and US EV maker, we are supplying the solutions for the battery applications. And for the battery applications, one thing is highly critical, the continuous service temperature that we call the RTA. Starting from the 90 to 150, we have developed a material in the PA66 and PA60 to meet the RTA more than the 160, and if we could see the value more than 220 also. This is for the household applications where the scope is generally referred as a white goods. So in flame retardant solutions, halogen free, if you compare with our competitors, so we have developed the low density PP material for this white good applications, which has a lower density and better control shrinkage and higher GWI performance. And this antibacterial solutions, apart from the silver, so without silver we have developed the antibacterial solutions, and we have multiple certifications from the global body. And anti-static solutions, generally traditional anti-static solutions, after use of the 6 months it will come out to the surface, migrated to surface. So if you could see in the furniture showcase, so generally after 6-7 months it looks like a dull surface. So to avoid that one, we have developed a permanent anti-static solution. The migrations to the surface it will be very minimal over the time. And the paint-free plastic, this is also attempt towards the sustainability. So we have developed whichever the customer requirement color, avoiding the primer applications with painting. So we have introducing the pigment during the compounding process. So we have developed multiple color solutions including RAL and pattern, across all the polymer category. And for the metallic color, generally we face the weight line issue during the molding. So to counter that one also, we have introduced a spherical kind of the filler. So the weight line is one of the classical issues that we have solved recently. And the bio-based composite material, it has two different aspects. One is the bio-based composite, or to give a wood kind of texture to a material. So bio-based material, it is quite compatible with the polyolefin-based compound because of the thermal stability of the wood part is quite lower to be used in the engineering plastic. So in PP material, we have developed multiple solutions with the wood fiber. And this is the environmental stress cracking resistance. In the ABS, generally we face this cracking cracking surface over the time on the part. So for this one, we have developed new solutions to improve the environmental stress cracking with our patented grade alloy. And you could see from the ACM micrograph from the normal ABS and alloy, after this is a 10-hour acidic solution, there is no cracking. You see, this is the accelerated cracking environment we have tested. And this is the colorful laser marking in the LCD, majorly LCD customer and other automotive also they are demanding for the laser marking. So we have used the laser additive based the polymer compound. Now trends in apart from the automotive, we deal with the electrical appliances sector. So from the low voltage apparatus to our trend is more into the miniaturizations and higher safety and environmental friendly. So if you could see on the right side, this brominated nitrogen red phosphorus and phosphorus nitrogen, this is the core class of FR compound we have developed. And this is, as I said, from the every time the Kingfa is working on already developed nitro solutions from the first generation to second generation. If you could, as I mentioned, this RTA continuous solution is highly critical for the engineering plastic. If you could see after all the FR category, our RTA, we have tried to increase further compared to the brominated from 125 to 130. And in the red phosphorus also, this blooming is quite evident in the red phosphorus but PS6 compound. So white mark, white kind of deposition you could see from the red phosphorus. So in the second generation we have solved with the new kind of formulations. This is a nitrogen based PA66 system. In PA66 without the brominated halogenated nitrogen, it always behaves the V2. But in one field case we have tried to meet the V0 criteria in GWIT and GWF, which is critical for the as per the IC standard. And from the long chain polyamide, this is for the connector where the CTI, the comparative tracking index and the IPT inclined and tracking, these are highly critical. So in PA6 and 66, the IPT we could meet around 1.0 kilovolt, but with the long chain polyamide like polyamide 610, polyamide 612, polyamide 12, polyamide 11. So we have tried when we categorize them as a LCP long chain polyamide, we could say the IPT is more than 2.5 kilovolt. It is highest in the class with if you compare with our competitor. And for FR PPT, as I mentioned, there is 4 kind of FR system we have. So in PPT also we have developed both in the brominated FR, that is halogenated PPT, and non-halogenated PPT with the nitrogen and phosphate kind of chemical detergent. So bio-based polyamide, as I mentioned, that the RTA we have developed some solutions to cater that RTA requirement of 220. So we have developed polyamide 10T. So then the polyamide 10T, if you go to the chemistry, the 10 part comes from the acid. This is where we write from the castor bean. So in terephthalic, the benzene we have attached to the aliphatic chains for the better thermal stability. And in this class also, we have developed PA90, PA60, and all FR metal, including the brominated to the non-halogenated also we have developed. So this is more to our aim is to become the most respected manufacturer in the compounding industry. Thank you.
Thank you, Dr. Saroj. The first presentation is over. We have some questions for the audience, and whoever can answer it will walk away with the prize. Yeah, Dr. Mr. Narayan.
Good morning. In this presentation, there was a reference to the continuous temperature for the battery, EV battery. Can anyone tell us what was the temperature?
Just raise the hand.
92.
Is it right? 90? No. It's not right. Is it correct?
No.
No. Anyone? Anyone? 92.
120 is right.
It's right? Okay. Just did.
Subramaniam of Rainier is the same classics.
Kenya. Big clap to the Saroj sir. Thank you, sir.